Hello guys, this is Mehdi again, and in this video I'll first explain why do we use assembly. We use assembly first to write compilers like GNU and GCC in Linux, MinGW for Windows, create embedded systems and microcontrollers like for factories and like for controlling cars, controlling drones, systems that are sensible, that they use faster processing of data. Then we use it for real-time systems, like for writing games that needs to be fast and we don't need that lag, like for football games like PES or FIFA, when a player passes the ball to another player, we don't need lag time, or we see a lag in the screen or something like that. The pros of the assembly language: we understand the programming language, how do they work, and we get a better understanding of machines, like we know what happens under the hood. Cons Cons of assembly language is it is like for writing simple tasks we have to write more lines than if we write the same program in C or Java or Python. Must understand a little bit of binary, hexadecimal, and maybe octal basis. Don't worry, I'll explain it right now. So I'll switch to a Word document. Like for binary is a base that uses only zeros and ones, like we see in hacker movies and programming movies. First guys, let me make it bigger for you to see it. 0 in computer science in CS means false, or from another view it means that there is no current. There is no current passing. And 1 means true, and it means that there is electricity and electrons that are passing in the material. And the material. Sorry guys. Sorry guys. There are electrons that are present in the material. So, how do we use it to encode decimal values like 10 apples, 5 bananas? Computers doesn't understand 10 and 5, or A or P or B or A or N. So we have to encode these characters in binary base. How do we do that? For the alphanumeric values, each number corresponds to another value that we call ASCII values. Like A is 65, capital A is 65, Z is 65 plus 26, and it goes like that. So sorry, 10 in decimal is 1 0 1 0 in binary, yeah, and 5 is 0 1 0 1 in binary. How do we calculate this? Binary is working like that. Let me open Paint. 5 equals 4 plus 1, and 4 is 2 power of 2, and 1 is 2 power of 0. So binary will code on 4 bits, like we have 4 cases where we can encode this number. This one corresponds to 2 power of 2. This one corresponds to power of 1, and this one corresponds to 2 power of 2, and this one corresponds to 2 power of 3. So here we have 2 power of 2 and 2 power of 0. So we'll encode this one and also this one, which will give, we will encode this one, we'll write 1 in this one and also 1 here. So it will be 0 1 0 1. We'll do another example. Like for 12, sorry, I'll change this one. 12 equals 8 plus 4, which is 2 power of 3 plus 2 power of 2, which is 1 0 1. Oh, sorry. I'm so sorry for this fault right here. It is 1 1 0 0 in binary. So this is our first binary example. So how do we write signed numbers, which are negative numbers, in binary? In binary, we code numbers on 4 bits, or 8 bits, or 16 bits, or 32, or 64. Each one of these means that we have 4 placements, where the number of placements that we can write in binary values. Like for 4 bits, we have 4 placements, and for 8 bits we have 8 placements. And the bigger one is left for the sign, which means minus equals 1. We write 1 here, And for positive numbers, we write 0. Like for, if we want to encode 4, right here, we will write 1, 0, 0, 0, 0, 0, 0, 0, because it's a positive number. But for negative numbers, if we want to encode -4, we'll have to do some special calculus. Like, we encode 4 in binary, which is 0, 0, 0, 0, 0, 1, 0, 0. Then we switch each 0 to 1. Sorry for this 0, it's weird. 1, 1, 1, and 1. Then we add 1 to this resulting number. We add 1. 1 plus 1 equals 2, which is 10 in binary. So we write 0 right here, and we add 1 plus 1, which is again 0, and 1, because there is another 2 in here. 0 plus 1 equals 1, and then we have 1, 1, 1, 1, 1, 1, which is the negative expression of 4 in binary. This is for the sign. This bit is for the sign, which means minus if it is a 1. The same for hexadecimal. For hexadecimal, if we code our values on 4 bits, for example, we have 4 placements. This is the one for 16 power of 0. This one 16 power of 1. 16 power of 2. I'm so sorry because I'm drawing with my mouse and it is not so easy to write with the mouse. Then we encode each placement. We have, for hexadecimals, we can encode from 1, 2, 3, and when we arrive to 9, we start encoding by 10. B, 10 is A, 11 is B, 12 is C, 13 is D, 14 is I, and 15 is F. So to encode 15, like 15 equals 0, 0, 0, F in hexadecimal. So there is a lot of videos explaining how to calculate hexadecimals and convert from binary to decimal. This is a boring video, so I'm sorry guys for this video, and thank you for watching this. I forgot, you must write an H for hexadecimal, and O means octal. It's going from 0 to 7, and B is for binary. So thanks for watching. I hope I'll see you in the next video. I'm so sorry for this video, it's so boring, I know it. So thank you for watching. See ya.